preservation is a technique to protect food from spoiling, thus extending the shelf life and quality of food. Thermal as well as non-thermal methods are widely applied to minimize microbial spoilage and extend the shelf life of food. The purpose of preservation of food are to preserve quality and nutritive values of food, to overcome inappropriate planning in agriculture, to prevent spoilage and eliminate waste, to produce value added products, to provide variation in diet when one or more quality attributes of a food has reached an undesirable state or level defined by manufacturer according to the criteria when product is sellable. For example, unsuitable for consumption, shelf life, best before date or pack date, use by date or expiration date. There are several methods of food preservation such as heat treatments including pasteurization, sterilization, canning, evaporation, dehydration, smoking, etc. Low temperature methods like freezing, low temperature storage, etc. Chemical preservation where application of sugar, salt, lactic acid, vinegar, benzoic acid applied. Fermentation, example being acetic, lactic, alcoholic, etc. Physical means modified atmosphere, vacuum, filtration and clarification, agents to prevent biological and chemical spoilage, etc. Combination of two or more of the above, alternate non-thermal techniques, new emerging techniques for preservation of food. Emerging technologies for controlling spoilage of food. Non-thermal methods to preserve food are high hydrostatic pressure, pulsed electric fields, light pulses, irradiation, oscillating magnetic fields, modified atmosphere packaging, etc. High pressure treatment. Food are subjected to elevated pressure along or combination with heat, sound, etc. to inactivate microbes for extending the shelf life without much changing in physical and chemical qualities. Intense pressure as high as 400 to 600 millipascal is applied at ambient or low temperature which cause minimal effects on taste, texture, appearance and nutritional value of food. High hydrostatic processing HHP and ultra high pressure processing UHP are the different techniques used. High pressure causes the phase transition, chemical reactivity, change in molecular configuration, chemical reaction and thus destroy the microbes. Parts of HHP machine include high pressure vessels with closure, pressure generated system, temperature control device and material handling system. High pressure increases the food temperature and hence food controlling system is used in combination for better performance. Water is widely used as pressure transmission media. Food are packed and sealed in flexible packages for treating with HP. HP processing can be done in batch, semi-continuous and continuous processes. Continuous operation is suitable for processing liquid food materials such as milk, fruit juices, etc. HP process is operated at 100 to 500 millipascal for 5 to 10 minutes. HP processing has marginal influence on nutrient. High pressure processed products are commercially available in United States, European and Japanese retail markets. These are fruit smoothies, ready meals with meat and vegetables, oyster, ham, chicken strips, fruit juices and salsa. Pulse electric field. Pulse electric field is an alternate food processing technology. Application of pulse electric field can be proposed for the inactivation of vegetative bacteria and yeast at ambient or even low temperature, that is around 4 degrees C. Minimum changes of the food takes place at low energy consumption even if a high electric field strength is applied. This technique involves a short treatment time about 1 second resulting in a negligible ohmic heating of the processed food. The use of PEF for inactivation of vegetative microorganism has been extensively studied. Successful results were obtained in processing of several liquid foodstuffs including apple juice, milk, liquid eggs and pea soap. PEF has been proposed for non-thermal pasteurization of liquid foodstuff. Pulse light. The spectrum of light in the ultraviolet to the near infrared region is used for pulsed light treatments. Pulsed light is released from accumulated storage capacitor electrical energy to do work in much shorter time and thus magnifies the electric power. Pulsed white light, which is called PWL, or pulsed UV light, is generated from high power xenon lamp. Intensity is as high as 20,000 times as intense than sunlight. Light in the range of 200 to 400 nanometer cause disinfection effect. Light pulsed can inactivate microbes at faster rate. PWL destroys microbes and spores by UV light damage of nucleic acids and cellular components and cell wall destruction by instantaneous heating processes, and effectiveness varies with wavelengths. Thus, undesirable wavelengths are filtered out before treatment as light pulses can induce photochemical or photothermal reactions in the food. Pulse light can be applied to decrease microbes from food also. PL can effectively inactivate molds in bakery food. Similarly, shrimp treated with pulse light and stored under refrigeration for 7 days remained edible, while untreated shrimp showed extensive microbial degradation and were discolored, foul smelling. PL effectively disinfect dry cottage cheese. Challenge included with the Pseudomonas species with an energy density of 16 joule per centimeter square for 0.5 millisecond and caused 1.5 log cycles reduction of microbial population after 2 flashes of treatment, where the curd surface treatment was increased by 5 degrees C without losing the sensory qualities. Pulse light is also able to reduce psychrotropic and coliforms on the fish tissue surface without affecting the sensory qualities during refrigerated storage. The eggshell surface contaminated with Salmonella species can effectively be reduced by pulse light. Irradiation, ionizing and non-ionizing radiations are the emission and propagation of energy. Microwaves, ultraviolet rays, X-rays and gamma rays are used in food preservation. Shorter wavelengths cause maximum microbial destruction. Gamma radiation from cobalt-60 is widely used in sterilization of food, packaging materials, etc. It can penetrate in the food materials, generates peroxide from water and cause microbial inactivation. Redapertization is a process for extending shelf life of food using radiation. Radiation of 4.5 to 5.6 megaRad is used for sterilization of meat products. Ultraviolet and non-ionizing radiation is powerful bactericidal agent at 2600 angstrom. It destroys proteins and nucleic acid by photochemical changes. Due to poor penetration power, it widely used to destroy microbes on the surfaces. Oscillating magnetic field. Oscillating magnetic field OMF is one of the novel non-thermal technologies for the food preservation by destroying the microorganisms. Magnetic fields inhibit DNA synthesis, change the orientation of biomolecules and biomembranes. OMF couples energy into the magnetoactive parts of large biomolecules with several oscillations. OMF inactivates microbes in pasteurized food. The 5 and 50 Tesla field strength is required for effective inactivation. OMF treatment of food is done in sealed plastic bag and subjected to 1 to 100 pulses with frequency of 5 to 500 kilohertz at 0 to 50 degrees C for 25 to 100 millisecond. Magnetic fields causes inhibition in the growth and reproduction of microorganisms. Up to a 3 log cycle inactivation was achieved with no significant increase in temperature or appreciable changes in food quality as judged by the consumer panelist. Plasma technology. Plasma is the fourth state of matter and is distinct state of matter containing a significant number of electrically charged particles. Plasmas are estimated to constitute more than 99% of the universe. A gas becomes plasma when the addition of heat or other energy causes a significant number of atoms to release some or all of their electrons. Those atoms and the resulting electrically charged gas are said to be ionized. When enough atoms are ionized, significantly affect the electrical characteristics of the gas. It is plasma. Non-thermal plasma, which is called NTP, relies on electric discharge into air or liquid to produce mixtures of energetic atoms, highly reactive radicals, ozone, etc., which have potential to destroy microbes. Plasma inactivates both vegetative cells and bacterial endospores. Three basic mechanisms have been attributed to the inactivation of microbial spores. These include destruction of DNA by UV irradiation, volatilization of compounds from the spore surface by UV photons, and erosion or so-called etching of the spore surface by absorption of reactive species like free radicals. Potential application includes pasteurization of liquid food products, disinfection of processing equipment, plant floors, packaging materials, city water and wastewater treatment and air pollution control, etc. The primary advantages of plasma processing as a potential tool in the inactivation of microorganisms have been cited as minimal thermal denaturation of nutritional and sensory properties, reduced energy requirements for adequate processing, and potential treatment of food inside a flexible film package. NTP technologies can be used for non-thermal pasteurization and sterilization of food and biological fluids. Water, apple cider and orange juice are inoculated with E. coli and Salmonella, and NTP was capable of killing E. coli and Salmonella. Cold plasma has many advantages over completing preservation technologies such as irradiation, chemical sterilization using ethynyl oxide or disinfection treatment using chlorine, which may have detrimental sensory effects on treated food products or are being phased out because of safety concern. Electrolyzed oxidized water. Electrolyzed oxidized water EOW has a strong oxidation potential and a shortage of electrons, giving it the ability to oxidize and sterilize. EO water has strong bactericidal effects on most pathogenic bacteria that are important to food safety. EO water is produced by passing a diluted salt solution through an electrolytic cell within which the anode, and EO water may inactivate both vegetative cells and bacterial endospores. Three basic mechanisms have been attributed to the inactivation of microbial spores during EO water treatment. These include the destruction of DNA by UV irradiation, volatilization of compound from spore surface by UV photons, and erosion or so-called etching of the spore surface by absorption of reactive species like free radicals. Modified atmosphere packaging, which is also called MAP, has been extensively researched and used for many food products to limit microbial growth. The active gas in MAP is, for example, carbon dioxide in aqueous medium retards the growth of gram-positive and gram-negative organisms. The magnitude of the effect on the different phases of growth depends on the organism. For example, the lag phase of growth of Pseudomonas fluorescens increases with increasing concentration of carbon dioxide. Other organisms are similarly affected but to different degrees, for example, Listeria monocytogenes. The direct and indirect mechanisms by which carbon dioxide affects microbial growth and metabolism are not entirely clear, even though the topic has been studied in detail. Now, let us summarize. Consumer demand for fresher, higher quality and safer food has promoted research on non-thermal methods of food preservation for inactivation of microorganisms and enzymes as an alternate to thermal processes. However, the high resistance of certain enzymes and microorganisms to non-thermal processes, especially bacterial spores, limit their application. To expand the use of non-thermal processes in the food industry, combinations of these technologies with traditional or emerging food preservation techniques are being studied. Non-thermal methods to preserve food such as high hydrostatic pressure, pulsed electric fields, light pulses, irradiation, oscillating magnetic fields, modified atmosphere packaging (MAP) are gaining attention within the food industry and research laboratories. They offer sound alternatives to conventional thermal process where quality aspects and costs are becoming a concern. Thank you.